Okay, so lesson 5, sequences and series. So you guys actually did this, a lot of this stuff in Math 20-1 with sequences and series. You guys remember all of that, right? It's a long time ago now. So yeah, it's kind of remind you. So a sequence is a list of numbers written in a definite order, right? So that could be, so T1, T2, T3, all the way to T whatever, right? So just that list going up. So in many sequences, the general term Tn can be defined by a formula. So we went through some of those. And yeah, sequence we thought of as a function whose domain is a set of natural numbers. So let's say if we have, for this sequence, right, Tn is equal to 1 minus 2 over n. And it says list the first 6 terms. Okay, so T1, we would say. So T1 in this case would be, well, so that means you'd be like replacing the n with a 1, and then we'd be putting a 1 in for n. It's like a function, right? So T1 is equal to 1 minus 2 over 1, which is equal to, negative 1. Okay, so there's your first one. T2 would be 1 minus 2 over 2, which is equal to 0. T3 is equal to 1 minus 2 over 3, which is equal to a third. T4 you guys kind of getting it? I think I'm going to cheat. Is a half. T5 would be 3/5. And T6 is equal to 2/3. Okay, so in this case, what is T 1,000? So T of 1,000 would be 1 minus 2 over 1,000.
What's this trying to tell us? That it's approaching 1? Is that the point?
Yep. Okay, so now an infinite sequence is a list of numbers that has infinitely many terms, right? So you can see where this links to the last one now, right? So if we keep up that idea of a sequence, then we could go forever, right? So we could actually have like t at infinity, okay? So in that case, so let's say find the limit of the sequence defined in example 1 as n approaches infinity. So yeah, let's do that again. So we'll say, okay, the limit as n approaches infinity of 1 minus 2 over n. Okay, so what would that be equal to? 1. Yeah, let's do it right. So we'd say this would be the same thing as the limit as n approaches infinity of 1, right, just this first term, and then minus the limit as n approaches infinity of 2 over n. So this would be the same thing as 1 minus 0. So this is equal to 1. Okay. A series, so instead of the sequence, right? A series is the sum of the terms in the sequence, right? So this would be like we're adding them all together now. So the sum of the first n terms in the series is denoted by, and we'll see this notation, right? Sn. So we'd say like Sn, instead of there being commas in between all of these, you guys will see that there's addition signs between all of those, right? Okay, so we will only be looking at geometric series in this course. Okay, so the definition of a geometric sequence. So a sequence where you multiply each term by a constant ratio. So each term is going to change by like a constant like multiplication factor, right? Like an R value. So this is going to be our formula right there. Okay, And this is the one that you guys will see is on the formula sheet now. There's like the first one there. So can you guys find that? Okay. Okay, so this first term, or this first equation that you guys have, this is going to be to figure out what any term in that sequence would be, right? So you can figure out what the 5th term was, what the 10th term was, like any term that you like. Okay, so we'll be using that below. We'll just kind of leave that for now. The second one, these are actually the same formula, and they're just going to be to tell you what the sum of the numbers is up to whatever term, right? So it's Sn. Okay, so that's actually your second equation that you guys will see there. I think it's this one I put. Your R value, like when you do this, your R value is going to be your common ratio. So that's like what you're multiplying to get the next one as we're going. This will make a bit more sense as we get going. Okay, so like in this case, if I looked at this example here, right, you can see that we are adding these numbers up every time. The common ratio in this case would be what we had to multiply to get to the next one. So can you see what I had to multiply 3 by to get to 12? 4, right? And 12 by to get to 48? 4, right? So this thing's being multiplied all the way up. But you can also see as this thing gets bigger and bigger, right, as I keep going, am I ever going to be adding all these together to get to some number, right? Am I going to approach some number in this case? It's going to go to infinity, right? So this is what we call divergent, right? These things are getting farther and farther away. So this thing isn't going to have a limit that we can approach, right? This is going to be a does not exist situation again, right? If the numbers were getting closer and closer, right? Like if we were getting, smaller and smaller every time, so an R value of like a half, right? If it went down, 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 then the way that graph would kind of look, right, would look something like this, where it's going to be getting closer and closer to some number, right, as we're going up and up. Okay, so in general though, if the common ratio, if the R value is less than 1, then we're going to be able to find a limit for it. Do you guys know why I have those bars on the R? What do those bars mean? Yeah, it's the absolute value. Why is that important? Because R has to be less than 1, but what is this also kind of including when I write it that way? The sign doesn't matter. Yeah, exactly. So it's actually from like -1. So if this is like a number line, right? It's anywhere from -1 to 1, right? All of those numbers would give me a sum, a convergent series. Yeah. And if it was outside of that, like if it was over here, right? If I had like -2 or 2, so like -2 for my R value or 2 for my R value, those things are going to be divergent. So this is like a fancy way of showing that, right? The negatives just don't matter. Yeah? Okay. So in a convergent series, let's actually take the limit, which is this is just kind of showing you how this works. That if we say, okay, the sum of the infinite series, right, is the limit as n approaches infinity, what we can do is we can actually do the same little trick there. We can take the limits of each of these individual pieces. And if you take the limit of R to the n when R is less than 1, so it's a fraction, what do you get there? The limit of R to the n when R is less than 1 is 0, right? So what that does, that actually like simplifies our equation. We get to get rid of that term. So this whole thing, so the sum of any infinite series when R is less than, when the absolute value of R is less than 1, is this equation. So we can use that simple equation now whenever we like.
What does P stand for?
Some value, like any, yeah, just any number there. Does that make sense? Okay. Now, in a divergent series, it actually doesn't work out, right? Because if we try to take the limit as R of R to the n, right, when R is greater than 1, this thing is going to be divergent, right? And so the sum just doesn't exist, which is what we would expect, right? If we keep getting bigger and bigger and bigger, it's never going to approach some number that we're adding up to. Okay. Okay, so what happens when R is equal to 1? Okay, so if we think about it being equal to 1, then what what you could do too here is actually just think about this. If r was equal to 1, then that would look something like this, wouldn't it? That would be like, let's say our first term was 2. What would our second term be if r was equal to 1? 2. What would the third term be? You can see the pattern, right? So plus dot dot dot. What is this thing approaching? Infinity, right? This isn't going to work out. I'm not going to be able to approach some number. They aren't. If they were getting smaller and smaller, right, then it would start to approach some number that I was adding up to. In this case, 2 plus 2 plus 2, I'm getting farther and farther away, right? This thing isn't approaching anything. So I can tell just from reason that this is going to be infinity, right? But the other way we can do it is if you take the limit of this part, right? So the limit of 1 to the power, or sorry, r to the power of n, if it's 1 to the power of n, in this case, then that would be 1. So in the end here, this is like 1 minus 1, this is 0. And on the bottom, I've got 1 minus 1 is 0. 0 over 0 means indeterminate, right? It means it's not, yeah. But in this case, but it's actually going to be does not exist for like the reason we were shown above here. Okay? If it was negative 1, so if it was negative 1, this is another weird one, right? So negative 1, let's do it this way. So if we had 2, and if r was negative 1, what would the next one be? Yeah, negative 2. What would the next one be? 2. Negative 2. So what do you think? If we just kept on going with this for like infinitely far, what would the answer be? But what if I ended on a plus 2? 2. So you see where I'm going with this, right? Is it 0 or is it plus 2? So again, this one isn't going to work out very well. Yeah. So we'll just kind of leave it at that. It's indeterminate. We'll say it does not exist for our purposes, right? Or indeterminate. Okay, so let's get doing some. So now, so for this one, oh, sorry, and the last one there. Okay, so let's look at this one, right? So if we want to figure out the infinite or the sum of the series in this one, because it goes dot dot dot, so that means it goes on forever, right? So then let's figure out what we have going on here. So our a value, or like our t1 value, we would say is 16, right? So we're starting at 16. What's our r value?
3 over 4.
Yeah, how'd you figure that out? And not quite. You're really close.
Oh, it's negative 3 over 4.
Yeah. So what'd you do there to get negative 3 over 4?
Divide the second term by the first.
Yeah, we can see, right? Because whatever is happening here, I have to go 16 times some number to get to negative 12, right? So opposite of multiplying, we're going to go negative 12 divided by 16, which it would also work to go 9 divided by negative 12. It doesn't really matter which one you do. It's probably easier to use the first two, though, right? So we'll say negative 12 divided by 16. So that would be the same thing as negative 3 over 4. So now that I have that number, and I was to like wonder whether or not this thing would be convergent or divergent, whether or not we're actually going to be able to take the limit of the sum, what do you think? Are we going to be able to?
Yeah.
How come? How come we know we're going to be able to?
R is less than 1.
Yeah, we know it's going to because the absolute value of r is less than 1. So we know this thing is convergent. So now we can just throw it in. So now we know our formula. So the sum of the infinite series is equal to, and our formula is a over 1 minus r. So 16 over 1 minus, so 1 plus, right, minus a negative, 3 over 4. So if you put all that in, figure it out, 64 over 7. Okay. Now, how many of you guys have heard of something called sigma notation? Do you guys use that like in chemistry or anything? In physics, we did a little bit of it. Yeah, in physics 30, we were doing it, right? Yeah. So sigma notation is just another way of kind of writing this now. We can actually do these series using this symbol. It looks super fancy, right? So the way this works is if we had something like this, right? So find the sum of this example. Well, mine says n minus 1. That should be equals 1. Or something. Did you guys say equals or minus? Equals. Okay, good. Okay, so the way this works is it means we start at 1 and we end at k. So it's like you start at the number on the bottom and you end at the number on the top. So this would be, we're going to figure out this equation for n equals 1. We're going to figure it out for n equals 2, 3, 4, and 5, right? And then since it's the summation, that means we're going to add all of those terms together. Okay, so in this case, what we can do, you could actually add them all together, right? So I'll do that in this case. So we'll say 4 times 1 minus 3 would be the first one, which is 1, plus, and then it would be 4 times 2 minus 3, which would be 5. And then 4 times 3 minus 3, which would be 9, plus 4 times 4 minus 3, which would be 13, and then 4 times 5 minus 3, which would be 17. So all of that together, if you add them all up, is 45. Okay, so now a geometric series can be written in sigma notation, also using the formula for the general term of a geometric sequence. So in this form, right? That was your first equation on your formula sheet there. Okay, so we can use it. We can use it with this as well. So let's say for 5 here, if we had this one, then let's figure out what we have going on here in this one. So here, I'm going to write it one more time. So if we have the sum, so as n's equal to 1 on the bottom, we have k on the top, of a r to the power of n minus 1. So now let's figure out what a few of these things are, right? So it says, write the following geometric series using sigma notation, then find the sum of the first 8 terms. All right, so let's figure out first, let's say what our k value is. So what's k going to be in this case? 8, yep. First 8 terms, right? So that's what's going to. What's our a value? 2, yep. It's our starting value. What's our r value? Right, minus 3, and that came from going negative 6 divided by 2, right? So we kind of have everything we need, don't we? So let's write it out again. So we'd say, okay, the sum, when n is equal to 1 and goes to 8 this time, my summations are terrible. It was worse. Okay, of 2, so a is 2, r is negative 3, and then n minus 1. Okay, now we could do it for each one and add them all up again, right? But the other thing we could do, we have our second equation there, right? Remember the one that was a 1 minus r to the n over 1 minus r? Do you remember what that equation was telling us? So this one, you guys have it, so you'll always be able to look back to it. But it's going to be the sum at any given number. So if I threw like an 8 in for this, which we're going to do in a second, it's actually going to do all the work for us, right? We won't have to write out every term. It's going to tell us what the sum of those things is just by throwing an 8 in for n in that case. Okay, so we're going to go, so our a value is 2, and this would be 1 minus negative 3 is our r value. And like I said, so our n now, we're going to put 8 in there. Over 1 plus 3. So that ends up being negative 13,120 over 4, which is equal to negative 3,280. For this one? Oh, for your R value. Oh, for this one, yeah. Sorry, it would have been minus though, right? So it was like minus a negative. Yeah. So yeah, I skipped a step. Thanks.
I found my sheet there is a different one where, like the Rn.
Okay, the sum of an infinite series can be written in sigma note. Oh yeah, so same thing. So saying the same idea there. Find the sum of this series now. So now it's written out for us. So it's n. N is equal to 1, and it's going to infinity of this one. So let's figure out what we got going on here. So our a value would be what? Yeah, this is where we'd start, right? And you can kind of see that because that would be like, an exponential form. That would be where we started. We can know it from that. But the other thing we could do, if you were unsure, is let's make the very first term n equals 1, right? So if I threw a 1 in for that, that would be 1 minus 1, that'd be 0, right? What is anything to the power of 0? 1. Do you see how that like cancels out all of that? And I'd just be left with 4 over 5. So that would be my first term, right? So 4 over 5. And then let's say for this one, what about my r value? Like, how do I figure this one out? Well, what do you guys think? So r, there's a couple ways to think about this. What's that?
Put 2 in for n.
Yeah, you could. I'll show you what's going to... So yeah, put 2 in for n. So what would that be? So that would be 2 minus 1. That'd be 1, right? So then my second one would be 4 over 5 times 1 over 3, which would be equal to 4 over 15. Yeah. And now, if that was my second term, so my first one was 4 over 5, and my second term was 4 over 15, I could divide those, right? So that would be 4 over 15. Yeah, right. Divided by 4 over 5. Flip those, and you end... Here, I'll actually do it. 4 over 15 divided by 5 over 4. Those cancel, and we get 1 over 3. Starting to seem like I did a bunch of that for nothing, didn't it? Can you guys see it from the equation? Yeah, that makes sense. That's like our b value in an exponential function, isn't it, right? That's what is going up by every time. I didn't really need to do all that because I can see it. Yeah, that's our multiplying factor anyway. So 1 over 3. I don't know if it was worth going on that tangent, but maybe. Okay. All right, so we know those. So is this thing converging or diverging? It's converging, right? I know it is because our r value is less than 1. Absolute value of it is less than 1. Okay, so then let's throw it in. So we know the sum, right? Because this is going to infinity, so I can use this equation. We'll say the sum at infinity is going to be equal to a over 1 minus r. So this would be 4 over 5 over 1 minus a third, which is equal to 6 over 5. All right, last one. For what values of x is the series yada, right? And they're making it more complicated with like the x plus 1 involved in there. For what values of x is this series convergent? Okay, so what's this even asking, right? So in order for it to be convergent, what needed to happen? I've said this a few times, right?
Yeah, so it should be less than 1.
Yeah, absolute value of r has to be less than 1, right? So let's kind of work this out a little bit. Let's figure out what r would be for this, even though we have like a variable going on there, right? So in order for us to figure out r, what can you guys think of like an expression we can make here to figure out what r should be, even though we got like an x in there? What were we doing before to figure out r? We'd always go t2 divided by t1, right? So let's do that again. Let's just stick to the plan. t2 divided by t1. Yeah, so let's actually just throw that in. So t2 would be 1 over 4 x plus 1 over 3 over 4. Now you could say dividing by a fraction is the same as multiplying by the reciprocal here to kind of simplify this, but you guys getting kind of good at seeing this too, where I've got a 4 on the bottom and a 4 on the bottom, they just kind of cancel. So we can just say right off the bat here, this would be the same thing as 1/3 x plus 1. Yeah, okay. So yeah, like I said, in order for this thing to actually be converging, this needs to be true, right? So what we're going to do here, we're going to say, okay, in order for this to be true, let's throw in our r, right? Because this was our r. That's what our r value was. So let's actually do the same thing. We'll say, okay, the absolute value of 1/3 x plus 1 has to be less than 1. Okay, so now let's make sense of this, right? Because do you guys remember when we were solving these like inequalities back in the day? Do you remember what we had to do?
Take both cases.
Yeah, both cases, right? Because there is a negative version that we have to account for and a positive version that we have to account for in this, right? So this is what we're going to do. We're going to do both of those. We're going to have case 1. Okay, so I'll do, so case 1. And that's going to be the positive version. So that would be 1/3 x plus 1 is less than 1. And I'll write, I won't solve it right now, but I'll just write both cases. So case 2 would be what?
Greater than 1.
Well, it's actually, I think the easier way to do this is just to take the positive and the negative. Whenever you have the absolute value bars here, it's just to consider the positive version of it and the negative version of it. So all I'm going to do is just tack on a negative out front. So negative 1/3 x plus 1 is less than 1. Does that make sense, guys? Okay, and then we just have to solve both of those. So solving inequalities is really similar to solving an equation, right? We just got to be a little careful with the which way it's flipped. I'll show you there's going to be something that happens in the next one. So let's solve this one. So we multiply both sides by 3. So we'd have x plus 1 is less than 3. And then we'd subtract 1 from both sides. So we'd have x is less than 2. Okay, so that's one of my situations here. And then let's do this one. So in this case, when I'll do the same thing. I'll multiply both sides by -3, right? Do you guys remember what happens though if you have an inequality and you multiply or divide by a negative? Do you remember what happens to the symbol? Yeah, it flips on. So what'll happen here is this will become x plus 1, but then I have to change the symbol to face the other way, so it's greater than 3. So that happens if you multiply or divide by a negative.
Shouldn't it be -3?
Yep, thanks. Yep. So -3, yep. Okay, and then subtract 1 from both sides, so we get x is greater than -4. Okay, so then we should probably write that out. So in order for this thing to be converging, we could say therefore x has to be greater than -4, and it has to be less than 2. Why can't it be equal to? Right, that was that example way back here when we had, nope, not that far. This one, when it's equal to 1, right? Do you remember how those were also diverging, right? So it can't be 1 or -1 either, so it has to be greater than or equal, or greater than or less than or whatever. Okay. Okay, and then just lastly, I'll show you one more method of solving those, because I know this is kind of new, right? We haven't done like a lot of like solving inequalities like that. One more method you guys could have done, if you liked that a little bit better, we could have said that the absolute value of r had to be less than 1. You could write that out a little bit different. We could have wrote that out as saying that r has to be greater than -1 or less than 1. That'd be the same thing, right? Probably a little bit better to look at. we could have done it in this form too. We could have said -1 and then replaced it with our R value, right? So in our equation there, it was 1/3 x plus 1, and then written out like this. And then if it's written like this, we don't have to worry about the absolute values, like taking the negative and the positive version of it. But we do just have to kind of like simultaneously do algebra to both sides, right? So if I'm going to multiply both sides by 3, I actually have to multiply this by 3 and this by 3 and this by 3. Okay, so this would be like -3, and this is now just x plus 1, and this is 3. And then when I subtract 1, I have to subtract 1 from everything. So -1 and -1. So we get x has to be greater than -4 or less than 2.